Today's presentation is on the project merge module. Let's quickly go over some of the features on this module. Probably the most important one is the ability for multiple engineers to work in parallel doing a project development. This could mean at the front-end design of a project, you could have multiple engineers working on a given model. Perhaps one engineer could be working on the sizing, another engineer could be doing the load flow analysis or motor acceleration. It could also be used at a later stage. For example, once a project is complete and it's in the hands of the owner, the facility owner or the guardian of the project, then the facility owner would like consultant A to do motor acceleration study while another consultant performs harmonics analysis or sizing expansion. Project merge has the ability to merge base as well as revision data. So for those of you who use revision data for arc flash mitigation or for doing overcurrent protection and coordination studies, we make heavy use of the base and revision data to present propose new changes to the client. Also, it has the ability to merge changes directly on the one-line diagram as well as the star TCC views. So for any project merge that someone does arc flash analysis, they create typically TCCs to validate some of the fault clearing time values. You can merge all of this information into a self-contained project. So let's talk about, before we jump into the example, let's talk about the project merge workflow. The way the project merge workflow goes is the process starts from a master project. So this has to be planned up front. The facility owner, for example, would create a copy of the project, and we're going to call this a master project. Then the facility owner or the project owner would assign a copy of the model, the master project, to a given consultant. In this case, we'll call them consultant A, B, C. Once the consultants go over the scope of work for the designated section or scope of work, they will in turn save the model as an OTA file, and we're going to go over that process. They'll hand this OTA file, which contains the database and any new created TCCs or expansions of the one-line diagram, back to the owner. Then the owner will have the ability to not just check in, but also manage, right? Review any of the work that has been performed. If the owner does not agree with a certain portion of the work that was performed, they have the ability to reject the changes so that they don't get reflected onto the master project. So let's quickly go over an example. What I have here is a small industrial system, and this system has been created, validated, and is now in the hands of the facility owner. The owner has the responsibility for keeping the model up to date and also doing any kind of expansion work or future work. So what the scope of work is going to require is, if we take a look at this section here downstream of the low voltage MCC transformer, we have an MCC that needs to be expanded. They're rolling out new production lines, and there needs to be the ability of having more motor loads connected to this MCC. So what the scope of work for consultant A involves is, number one, updating the proposed changes to the ETAP model with the additional motors, making sure that the protection and the coordination between the main and the load breakers is properly set, and at the same time upgrading the transformer. At the same time the consultant A is performing this work, the owner of the facility is going to also need to balance this low voltage bus here, because the way the system is set up right now, you have 175 kVA load connected only to phase A, so phase B and C also will need to be balanced in that case. So all of this work will be going on at the same time. So we're going to use project merge to show how these changes can come to be merged, how the data is going to be reviewed, and how the changes are accepted and become part of the model. So the first thing the owner has to do whenever creating the scope of work and also requesting the consultant does a project merge is they need to provide a copy of the master model. So what we're going to do first is we're going to generate a master model. The easiest way to generate a master model is by going to the file pull down menu in ETAP and selecting copy project to. We're going to say save changes, yes. And what we're going to do is in our ETAP folder, we're going to create a new project folder, and we're going to call this master project, and then we'll make it consultant A, for example. So inside this folder, we're going to go ahead and make a copy of the master ready to be delivered to the consultant. ETAP says your project has been successfully copied. We're going to click OK, and then we're going to close out of the master project. So now what we have is our master project and also a copy that is ready to be delivered to a consultant. Let's now pretend that the file is transferred to the consultant, whether it's an FTP or in some other means, and I'm now the consultant. The consultant will now come in, open the master project copy that was assigned to the consultant. We went ahead and open the file database here, and the consultant is going to get to work on performing the MCC expansion. So the first thing I'm going to do is, as a consultant, is perform a quick load flow analysis. I'd like to display power flow throughout the various branches. In particularly, I'm concerned with this particular section here. So I'm loading this transformer to almost 50%, and also what I need to do is I need to check what my protected device settings are. So I went ahead and turned on a data block here for my protected device settings. I could see here that I have for my main color hammer MDS main breaker, the size is 200 amps. For my motor load breaker, I have color hammer thermal magnetic breaker that is 100 amps. So since I'm going to be adding 3 more motors, I'm going to have to switch my main. I'm going to have to set new protected device settings most likely. And also, one of the things I need to do is I need to change the main low voltage transformer from 150 kVA most likely to about 500 kVA. So let's go ahead and begin with the expansion. I'm going to go into edit mode, and I need to make a copy of this and select move from dumpster. There's one. I need 2 more. So since I'm gonna be copying multiple, I just went ahead and selected copy paste, and the last one to keep my dumpster clean is I'll just go ahead and move it from the dumpster. So here's my here's the lineup of the motors. So I've performed the expansion here now. One of the things also I need to make sure of is I need to open this MCC bus location. I need to go over to the rating tab, and I need to change my MCC rating from 200 amps to 400 amps. I'm going to assume that my bracing is going to continue to be the same So I'm going to go ahead and just click OK here. So now that my bus rating is updated, we're assuming that every single one of these load breakers is 100 amps. I need to come in over to my main and change my sensor from 200 to 400 amps. So let me do that from the library here. I'm going to select not 200 but 400 amp frame. My sensor is also 400 amps. There it is. So there's my new sensor. I'm going to click OK. And before I create a TCC, before I go ahead and create my coordination curves, I'd like to also upgrade my transformer. So I'm going to change my rating here from 150 kVA up to 500 kVA. Give us a little bit of room in the future in case we need to connect any more load to that MCC. And then over for my impedance, I'm going to select typical impedance values. We haven't yet purchased the transformer. We don't yet have a data sheet from the transformer manufacturer. So what we're going to do is we're going to go with some typical impedance values for now. Click OK. And now I'm going to go ahead and perform a load flow analysis. I just want to make sure that none of my cables or bus or transformer is overloaded. As we could see, we open the load flow alerts. There are no critical alerts. Everything looks good. Nothing critical, just a couple marginal items, but nothing that is overloaded. So what we're going to do now is let's go ahead and pick my main protected device and the largest load breaker, which in this case all the load breakers happen to be 100 amps. I'll go ahead and create a TCC. There's that TCC. I think what I have is the maintenance mode. It automatically came enabled. There it is. Click OK. And there's my coordination curve. By default, the name of this TCC is called star 1. I like to rename it so it's easier for the owner. Once they merge the TCCs, these need to be correlated with the report. So on the report, I'm going to go ahead and call this new expansion MCC. New expansion MCC. That's what I'm going to call it. In fact, I'll put a letter Z in front, Z new expansion, so it shows at the bottom of my curves. There it is. We could also see if we turn on the data blocks, and we may just need to see data blocks for a couple of them. We could see here the settings, and we could also see the settings for the main as well. So now as a consultant, I'm done with my scope of work. These changes will be merged by the owner once they review the work. So as a consultant, as part of the report, I also part of the deliverable is to create a project merge. And the way I create that is in order for this to be merged, I need to generate an OTA file. So from edit mode, I'm going to need to go over to the File pull-down menu, select Data Exchange, select Project Merge, and select Export. And I'm going to perform a full export. So I'll go ahead and put this under the same project file folder. I'll call this master. I'm going to call this expansion. MCC Consultant A, the name of the consultant, for example. ETAP will then generate an OTA file that contains all of the TCCs, all of the work that has been performed, all the upgrades. And now we go ahead and close out of the project. Now, if you recall, we spoke, or we talked about doing also some kind of balancing, phase balancing at the same time that consultant was doing the expansion. So what I've just done now is I went back to my original file. I'm the owner now. I'm logged in as the owner, and I need to balance the loads at this particular location. So the easiest way to go about it is, again, I'm just going to select the single phase branch. I'm going to select copy, and I'm going to paste. This is going to be my phase B, and this is going to be my phase C. So before I connect each one of these phases, I'll move them into place like that. And going into the phase adapter, I need to just make sure that I have selected the correct secondary or output for each one of these phase adapters. So I have all the way on the left is A, the middle one is B, and this one on the right hand side is C. Okay. So now that I've connected here my all my phase taps, I now have a more balanced load profile at that low voltage bus. So now what I need to do is I need to take the OTA file that was created by the consultant, and I need to merge all the work that was performed right here at that location. So I'm going to go ahead and save my my project file, and then I'll come over to the data exchange, select project merge, select merge from, and I'm going to pick and choose that OTA file that was created, the expansion MCC file that was created by the consultant. I'm going to select OK. So I would have to do this for all of the parties that were involved on this project merge. In this case, it's just one other party, consultant A. Select OK. This is the project merge and sync wizard, basically a manager that allows the owner of the facility to see if any files have been deleted, for example. So if the consultant who performed the work actually deleted any of the original work, then this action here would show files that have been deleted. Anything that has been added shows as add, and anything that has been modified shows here as modify. So this is all of the changes that I'm going to import, right? Anything that has been modified or added. Additionally, I can also, as the owner, expand any of these elements. In this case, my transformer, 150 kVA transformer, has been upgraded, and then this is the window or the view that shows the new impedance and the new proposed values for the transformer. So I can actually review. This is a powerful tool because this is actually changes that I can review before I accept the work. So from here, I can either accept by checking all of these fields or reject individual changes. So I'll go ahead and accept all of these work. I've gone ahead and reviewed everything. I reviewed the report by the consultant. I also need to merge the TCC. So before I click on merge one line diagram, I need to also go into merge TCC. And if you remember, there was a TCC that was created. So if I were to filter by add, there is that TCC that has been created as part of the expansion. Okay, so it gives you the elements that are on it. All of the other TCCs have an action of none, which means no changes were made. Also, there were no TCCs that were deleted, so I feel safe merging all of these changes. So after I review all of this, I select accept to add the new TCC, and I just now go ahead and select merge one line. And as you could see, it will automatically bring in all the changes. So this is the master project. It automatically brought in the changes for the expansion. Most importantly, it also keeps, right, the changes to the single phase balance loading that we perform. So I'm getting ready here to do perform a load flow analysis with all of the changes. and it seems everything checks out okay. Okay, this now becomes my new master project. So I just go ahead and click File, Save. To wrap this up, go over the some of the benefits. As you could see, the main advantage of using Project Merge is to drastically reduce time, be more productive, especially when you have consultants helping you with the work. So at the end of the day, it's just a matter of increasing productivity and savings. I hope this has been useful. I will stay for another few minutes, answer any questions you may have. Please go ahead and post them on the webinar application. Thank you, everyone. Have a good day. Bye-bye.